Hey guys, this is Professor Janacek. I want to talk about power series. I want to go over another example of a Maclaurin series. Remember, the format of a Maclaurin series is that it's f of x is equal to the sum as k goes from 0 to infinity of the kth derivative of f evaluated at 0 over k factorial times x to the k. And this is just a Taylor series centered about x equal to 0. So let's try the example where we try to find the Maclaurin series for e to the x. So in this case, our function f of x is e to the x. First thing we do with these is we'll find the kth derivative, and then we'll evaluate those derivatives at 0. So the first derivative of e to the x is, I know it's a tricky one, it's e to the x. How about the second derivative? Also tricky, right? E to the x. Any idea about the third derivative? Yep, you got it. E to the x. All right, this is a pretty simple series to deal with. Let's go ahead now and evaluate these at 0. Well, e to the 0 gives us 1. First derivative at 0, also going to be 1. Second derivative at 0. All of these will be 1. I think we've got that down. So looking at our function, e to the x, let's see if we can write out the Maclaurin series for it using that pattern there at the top of the page. It's going to be the sum as k goes from 0 to infinity of the kth derivative of 0 at k over k factorial x to the k. I am in the habit of writing this down. I think it's good practice so that way by the time you get to needing it, you'll have it kind of memorized if you do it on all the examples when you're working with it. But let's see, we know that all of the derivatives in this case have the same form. Oh, I could do better. All right, all of the derivatives have the form e to the x. Of course, we're evaluating this at 0, so they all look like e to the 0 over k factorial x to the k. But e to the 0 is always 1. So we end up with e to the x is simply the sum as k goes from 0 to infinity of x to the k over k factorial. Not so bad. Using this information, what would be the Taylor series for f of x equal to e to the negative x? Well, we know that e to the x is the sum as k goes from 0 to infinity of x to the k over k factorial. Let's simply replace that x with a negative x. So that gives us the sum as k goes from 0 to infinity of negative x to the k over k factorial. You might recognize that this is alternating negative 1 to the k, x to the k over k factorial. And there we go. How about f of x equal e to the negative x squared? Well, similarly, now that we know what this is for e to the x, we'll simply replace that x with negative x squared. Again, I recognize this as alternating. So I can write this as negative 1 to the k, just to identify it as an alternating series. And then x squared to the second power, that's x to the 2k over k factorial. And there you go. Enjoy!